Hi everyone. I'm going to be talking about MFC today. So just in case, I will give you an advance warning. My kids are around at home right now, so if they walk in, please be gentle and bear that in mind. So what are we talking about with MFC? Well, first of all, the point of these sets of lectures is going to be to look at event-driven architectures and sort of graphic user interfaces, two of the things that we have to cover in BIT2400. Another part of this is that I wanted to show you guys or expose you guys, much like to a virus, I guess, expose you guys to MFC and how you can do visual layout tools. Toolkits like MFC and especially the GUI layout editor they're good things to have been exposed to at some point in time during your early programming career. You will see other cases like this later on. They all sort of follow a similar pattern. So if you do Android development later on, for example, it's going to look a lot like MFC. They're not going to be exactly the same, but they're going to be a lot of things in common. So let's get into some of the nitty-gritty details. First of all, MFC applications, you're going to see a lot of code, a lot of code, a lot of boilerplate code. I don't know what half the stuff means. You don't know what half the stuff means. I'm sure the people that wrote MFC did not know what half the stuff means. Well, they probably do. But the point is that you're not supposed to know everything about MFC. You're not supposed to know every single thing that every single function does in order to understand it. This is exposure for you guys that you should expect if you ever have to program in any way, shape, or form, unless it's purely your own code. Being able to use somebody else's code is a critical, and to know which functions to look into and which ones to not look into is a critical skill to try and cultivate. On top of that, even if you're writing your own code using some other person's library or things like that, it is sort of a necessary skill. And it's a skill that's a very intimidating thing to acquire at first. That's why we wait until 2400 for it. This kind of stuff is really hard to fit into slides, so just letting you know. I do a live demo of it next, I guess. But at the same time, we're going to be talking about it from a theoretical, step-by-step, slide-by-slide standpoint. And the slides are based on Audrey's slides. The reason they're based on that is because I'm not an MFC fanatic. I'm not an MFC expert by any stretch of the imagination. I've done a lot of other things, but MFC is one of those things you learned it when you needed to do something with it because it's so big and so convoluted. I don't particularly love it as an approach, but that leads us to a very, very specific thing. So this is on your homework. I'd like to point out the fact that people do this set of that do MFC just enough to get by with this course, and some people really enjoy this. But a lot of times I will say, it's not on the exam. We have a half of an assignment to do with this. Therefore, and we have a half assignment to do with it. So just do enough to understand it. That's it, right? You're not expected to become experts or anything along those lines at MFC. And so a lot of people just sort of blow it off. And then, you just need enough to play around with it. So just say that you have been exposed to it. It's not on an exam. We're not going to be grilling you later on with this. MFC itself is extremely old, and it will look very old. It will look antiquated once you actually get something up and running. It will look like an older version of Windows. Maybe Windows now. But it's Windows specific. It does not work on a Mac. So if you do not have a virtual machine set up yet, you need to set it one right now, like right away. You cannot do this assignment any other way. And one of the requirements for this program is that you have access to a Windows machine. So virtual machine is your friend right about now. In case you haven't done it, that's your fair warning, right? Don't tell me the night beforehand, oh, I did. Why can't I do this on a Mac? Because we told you. And the degree program itself is very explicit about this. This is meant to be an initial exposure to GUI layout tools. And all these other tools that you might learn are going to be not exactly C++. They're going to be stretches from C++ a lot more than MFC is. Or I might say, oh, let's do Android development. Okay, well, that's a different thing altogether. It's a different language. I needed something that was specifically C++, which is kind of hard to find right now for GUI tools. C++ does not have a built-in GUI tool. And things like Qt, if you try something like Qt, yeah, that was my family if you overheard them. Things like Qt, for example, are huge. So I'm talking well over 5 gigs on my machine, and I was not going to get you guys to install all of that, this monstrous thing, only to wipe it out 2 days later, right? I thought, a bridge too far. So Qt, there are some libraries out there that allow you to do a cross-platform development, but since you have to have Windows, and since this is well documented, and since there's nothing new under the sun when it comes to MFC, it seems relatively easy to do as an assignment, just to dabble in it. Given the course constraints, I thought this was the best choice. You can disagree, but it was not by accident. It was not because I'm trying to be a jerk. It's because, given the fact that we only know C++, I can only assume you know C++, and given the fact that I'm trying to make it as easy as possible for you, this was the best, but give you exposure to a GUI layout tool, this was the best choice. Okay, so our job right now is to focus on event-driven architectures, event-driven programs, which we'll see, and we're going to do some more of that when we look at model view controllers, MVC, very different thing, but we want a sort of a high-level view of MFC applications. We want to learn about how to use MFC classes and MFC calls, and we want to get exposure to app wizards and the class wizards. But this is just meant to be dabbling in it. So the tutorial will dabble in this, and you'll see lots of instructions, very step-by-step instructions on how to do something. And for the example that we're going to be going over, it's very step-by-step. Your assignment is not step-by-step, is not constrained, but that's the point of it, was have fun with this. It was not something specific I'm looking for. I want you to make an MFC application that sort of satisfies certain criteria that you have to be able to put in input and it outputs something. That's it, right? It's meant to be play around with this so you get exposure to it, have, be creative, and then we can move on. So when we're talking about user interfaces, what's so special? What is so hard? In fact, if you talk to people outside of your degree program, if you talk about people from the when I'm teaching this to NET students and OSS students, I'll get a lot more pushback than I'm presuming to get from you guys, because a lot of people that do back-end stuff, server-side stuff, like command line programs. They like the simplicity of building up a new program, and they actually don't want to worry about the user interface because it's a pain in the backside to deal with. A graphic user interface is called a WYSIWYG interface. So it's what you see is what you get. If you see a button and you click it, you get the button moves or interacts. Your user interacts with graphical objects. It's designed to be more intuitive. It's designed for recognition rather than recall, so you don't have to remember what all these various commands are, right? When you're doing command line, oh, it's a -T and then it's a this, that, the other thing. If you've ever used Git, you know the challenges of command line programs. Though that's not the point of a graphic user interface, is to make it more intuitive, and so you don't have to memorize stuff. You can search for things. You intuitively understand things. In fact, maybe you don't like graphic user interfaces as a result of this, but I would not be your instructor today if it wasn't for the GUI, because quite frankly, I would not have picked up a computer. When I tried to learn how to program when I was a kid, I guess, I hated all of the fiddly diddly crap associated with programming in it from a command line. As soon as Windows 3.1.1, yes, I'm that old, as soon as Windows 3.1.1 came out, I was home, right? It made sense. I could deal with it. I didn't have to memorize stuff. It wasn't a matter of having some kind of cheat sheet for like, oh, in order to do this, I need to put in these instructions. It was just intuitive. It's one of the reasons I do what I do, to do the research that I do. There are other user interfaces. There's optical user interfaces, speech-based user interfaces like the Siri or Google Home or any of these other things. all are speech-based interfaces. So this is not the only game in town, but it's well documented. Most people know what I'm talking about when it comes to a GUI, but it leads to other issues. We'll talk about those in a second right now. So the difference here is, let's say I have a Goblin Gnome game over on this side. This is Audrey's notes, if you couldn't tell. And it is a graphic user interface, is a simple command line interface. And every single time you do a turn and your gnome moves over a certain amount or your goblin moves over a certain amount, right? But you're just typing in something and it spits out that information again. If you ever use those old MUD systems, you know what that is, but most of you probably haven't. This, on the other hand, is Minesweeper. Very simple game as well. But how do I choose which block I do? I don't type in A1. I click the darn block, right? It's an intuitive approach to how to interact with things. Especially when we have objects, it makes sense. The object on the screen is the object in the data set, and they sort of map together. The point of this being, notice that this, you type in something, you wait. You type in something, you wait. By the way, that's my wife painting, in case you didn't know what the heck that sound is. I'm not in an earthquake. This, on the other hand, I can click, and I can rapidly click all these things. In fact, how many of you have dealt with that with your family members, right? So let me just go back a step. I think I have it in a later slide, but right, if you've asked your mom or dad, at least for my parents, and I think for a lot of older people my age and older, you ask them to start Chrome, and what do? They double click, right? Or maybe your grandparents, right? You double click, right? Even if you're not supposed to. Or they double click, nothing happens. They double click again, and they double click again. Well, they're not, and now you have to deal with the user that clicks random things, and what do you do in those situations? With a command line, they just wait, right? You set up, you push enter, and you wait for the program to get back to you eventually. You could type all you want afterwards, doesn't matter. You still got to wait for the program to get back to you. It's a batch, right? You do something, and the application goes off, does its thing, and then eventually comes back to you. A GUI is, you can be rapidly clicking while something else is going on. And there's nothing you can do to stop users from doing crazy things. It's also why it's so much harder to test. Because with command line, you can make assertions or assumptions about what kind of thing is coming in. With a GUI, you cannot make any assumptions about how fast people are clicking the buttons or what crazy things they're doing. It's actually harder as a result to test a GUI. So what we're going to be looking at, we're going to be looking at painting programs for 4B, sort of drawing shapes. And for 4A, we're making an MFC dialog. You make one, and you're going to make one in the lab, and you'll make a different one for the assignment. Not the same as the lab. And it's just play around with this thing. When we do A4B, however, you're doing a shape drawing application, but you're going to refactor, as in move code around, but you don't have to actually write new functions, or you do not have to change the functionality. You just have to move code around to make it work using a model view controller approach. Okay, so when we talk about console programming, you ask a user for input, it does some processing, you spit something out, you ask the user for more input, rinse and repeat. With application programming, you can't control when they're going to click stuff. You don't know how fast the thing is going to be drawn to the screen. You don't know how fast they're clicking their mouse. You don't know if they're moving the mouse around. You don't know if they're using the keyboard, what they're doing. So with a console application, it's sequential. With a Windows application or a graphic user interface, it's not sequential anymore. I need a new approach to doing things. I need events. So an event-driven architecture is going to be this. You register like you'd register for a mailing list, or you'd register for concert tickets, or whatever example you want to give, right? You do this all the time in other domains, right? I am registering for this particular, well, register for a course. Bit less like that. More like putting yourself on a mailing list, right? You pass in information. I'm going to register to find out more information about this band. And when more information about this band comes out, you get an email. If I'm registering for when a new product is coming out, or when Baldur's Gate 3 comes out, I put myself on a mailing list. And when new information comes out, I get that information. That's what an event-driven architecture is going to do. You're going to register for when you want information, for the kind of information you want, and when something happens, you get told. It essentially calls your function. The other application, or the thing that has this information, calls your function, says, by the way, new information came in. And now it's your job to deal with that information. I'm sorry if anyone doesn't like Baldur's Gate 3, but I'm quite excited. A little bit scared, actually, for that game, just in case it sucks. If Baldur's Gate 3 comes out, I would get an email saying Baldur's Gate 3 has come out. Now it's my job to go off and buy the game, right? But I wait until I get that email. The GUI has events, and it will call your program's functions. So your functions respond to the messages, and so it's sort of in a backwards kind of way. Messages can be generated by user actions, other applications, the operating system, whatever the case is. So a timer might go off. The operating system will tell you that the timer went off. The user might click the mouse 5 times. That will cause, the user's actions will cause a callback. It might be some other application change your data set in the background. You get an alert for that. It could be all sorts of different things. The point is, you are not in control. The user is in control. The user is non-sequential, so the user can give feedback at any time. The screen might draw 60 times a second, or it might be 30 times a second. It might be 10 times a second. It might be 120 times a second, where that your game or your image is going to be drawn. And just like your parents double-clicking all the time, right? As a result, it means you don't control the order of things, and that's a hard thing to get your head around. You are not in control. Something else is in control. You deal with a callback. That is very different than what you're used to. So you structure your GUI programs based on events. You say, when I get a mouse event, do this. When I get a key event, do this. When I am asked to redraw things, do this. I don't say go and handle mouse events. Now go, like, I do not have a loop where I'm just saying do mouse events, do this, do this, do this. Instead, I make an infinite loop, honest to God, an infinite loop where I wait for an event coming in. When the event comes in, I call the correct GUI component. In our case, and we'll look at this again in the near future, in our case, though, with MFC, when an event comes, all of that stuff, the main loop, that infinite loop, the intentionally infinite loop that keeps on going until some kind of exit event sort of pops out of the program while in the loop, all of that stuff is taken away from you. It's in MFC. It's generated boilerplate code. It's not for something for you to write. It is written for you. And all you need to do is hook in your events, your event functions, and everything else works. That's the difference. That's why some people really love MFC. There are some issues with it, but that's neither here nor there. There are no standards for GUIs, especially in C++. So NC, ISO, C++, for example, the type of C++, did not have any functionality for graphic user interfaces. People built stuff on top of that, like MFC, like WX widgets, like Qt. But all of these other platforms, every single one of them, or all of these other graphical libraries that do all this heavy lifting, like draw a button for you. Instead of you going pixel by pixel, changing the button, drawing a button, you call somebody else's library. They're not standardized at all. Everybody has a different API, a different application programming interface. Application advanced. Anyways, API. It is the interface that you call to make things work. And they're all different. And as a result, it gets a little bit squirrely. It gets a little bit weird. There you go. Application, programming interface. You call this set of functions that this other library has, and that other library then will call your functions later on. An API is a library. An API is a library that provides, it's the interface to the library that provides functionality that you needed. So an API allows me to, in C++, what you end up having for these libraries, oh wait, we've already done this, when I have the include some header file, like standard IO, like time, like, let me think of another good example, string. Those are all, they give you an API, an application, an interface into other functions, other code. So when I call some other function, it does its own thing. This can also, by the way, APIs can also be applied for client-server architectures, right? I send something along the wire to another computer via an API call, and the API call is just the interface that I'm allowed to access from another computer. It makes it a lot safer. It allows me to provide functionality within a software component. OpenGL for 3D graphics is an API, for example. And for Windows, by the way, most of the APIs come as DLLs, as in they dynamically link into your code. It's a dynamic linking library, or DLL. And essentially, including the header file allows it to link into your code. They're not executables, but yeah, we won't get into those gory details. I like this sort of story here. An API is normally released by a company or released by some group, whoever makes it. It's public facing so that other software developers can, they can design products around it. So for example, Amazon released an API for website developers. So when you make a website and you want to allow them to buy something directly from Amazon, you call the Amazon API for buy now. Okay. It gives you the hooks for allowing the person to just immediately buy a product from your website. Or if you want to put a video of something on there. Or if I have an API for when I make an Android app so that I can call the internal functions associated with Android to make everything work. But what I don't want to do is change that around. I need an interface that everyone can use, that I don't have to know how this thing is actually built. I want to have an API that allows the person to use the system without knowing how the system works. I should know how it was implemented. Much like with the vector class, which we'll look at later, but it's been alluded to. With the vector class, I can make a vector in C++. I don't have to know how it's implemented. You shouldn't know how it's implemented. Same thing here with an API. It really allows reusable components. I know what I'm aiming for. It's a unified method of accessing internal functionality, internal data, getting the information I want, and it prevents inappropriate access. The API that you build there, that's where you put all the error checking, all the testing, so that when someone does a DDoS attack on you, when somebody tries to do code injection into your JavaScript library, you don't have to know what these things are, but ways of hacking into other people's systems. The place you put the preventative measures, the place where you do all the error checking, is in the API call itself, not internal code. It also allows you to coordinate between users. One person does an API, the other person calls the API, and then now I don't have to worry if the server-side person is on time. I don't have to worry if they have a bug in their code. It doesn't affect me. I just call their API. It's a lot simpler that way. I can divide my concerns. I have this interface where these two programs are connecting together. And I don't have to know how they implemented things. That's the point. If I try and understand every part of every single code base, I will be driven mad. When I was at Google, their code base was, I think, 500 million lines of code. Nobody understands 500 million lines of code. Hell, I wrote 125,000 lines of code at Kotoka, and even well, actually, think I knew my code that I wrote myself, but good lord, over 500,000 lines of code, you can't keep it in your head, and you will forget things. An API allows you to sort of modularly think about your code and not go nuts. If you needed to worry about every single brick in a building, otherwise the building would fall over, you'd be in trouble. So I like telling this story about my wife. She works, I'm not going to say the name of the company, but she works in a mass notification company. A company where they had an API where people would be calling this API, and for a long while, if they would call the API and they wouldn't get a response, then their program would do something else. So they would time out they have an API, they make the call, and if it timed out, they knew that there was a problem with the system, and their logic, the customer's logic, did something else. And then the people at our company went, hey, that's the wrong approach. Let's return an error message. Which immediately, even if that's the right thing to do, it still broke everyone's code again, right? It still broke everyone's code. They were relying on this timeout event, and they no longer had it, and therefore everyone's code broke. And everyone was up in arms. Everyone was freaking out about how it was, we designed our system around this, and now you changed it. They were very upset about the API. So they did this emergency patch for their big customers, trying to make everyone happy. And so they helped all these customers fix their applications to work with a new version of the API. And then a month later, they changed the API again and broke everyone's code all over again. Yes, APIs have to be solid. They have to be stable targets, not moving targets, in case you're wondering. Okay. We're going to look at GUI libraries, and the common code is part of the library. So do I have an example of here? Okay. So normally involves a whole lot of code, and a whole lot of applications deal with that code. Normally, a common GUI library will involve getting and dispatching events such as painting events. Painting events, by the way, are for when you are drawing your application. It's just the drawing. Okay, painting events, mouse events, keyboard events, timer events, logic of the game itself. Code for the GUI, so look and feel buttons, is also being covered by this. So that transition didn't work very well, I guess. So look and feel of buttons. When I make an MFC application, it always looks the same way. It looks consistent with Windows. When I make a Qt application, it looks consistent to the operating system it's being run on. I want the same. Every button should look like a button so that people know what to do with it. And when I resize something, when I redisplay something, all of that stuff is all handled by these kinds of GUI APIs. But this means the library itself is upside down. The library calls your code. You hook things up, and the library tells you when it's ready to draw something, not the other way around. You're not telling the library to draw something. You are waiting for the library to get back to you. When the library gets back to you, then you can call the library code to how to draw a line, for example. The library has functions allowing you to draw lines, but it also calls your code to say, hey, by the way, we are about to redraw stuff. Start redrawing. You are waiting for the library to tell you when to start. Okay. So with event-driven architectures, you have to register for events, like we talked about earlier, and all registered function. And when an event occurs, all the things that register all get of an event. So if 400 different programs all are registering for a callback, or 400 classes are all registered for a callback, all 400 get an event sent to them. They all get, that function gets called 400 different places. This includes error messages that you may have, painting and drawing, and mouse events. The program starts, messages are processed and dispatched, and so you will get messages being sent to your application, and then it gets sent around inside your code. I don't know if I have this see it in action thing, so hopefully I have a good example of this. So I wonder if I've already recorded this video, but I'll record it again anyways. I'm going to do Visual Studio. Come on, anytime. Okay, and by the way, this is just for other students from another class. Shapes, model view controller. Okay, do you want to remove that? Yeah, yes, I'll remove that. I might have to open it up another time. Open project solution. All right. Wrong year. In class code. Do I have it in class code? Let's see. MVC. This I have to move over to your assignment 5, by the way. Well, it's enough for us to look at it. Here is my Microsoft Foundation. This is a model view controller, not using MFC, but we'll still look at it anyways. Here we go. Anytime when this thing starts. So, I have a bunch of callbacks. This is all boilerplate code. I did not write pretty much any of this. Given right away, given right away, given right away. Here, by the way, the H stands for handle, meaning pointer. A handle to an instance of the particular window that we're dealing with. Here's a callback. So Windows processing callback, where I get some kind of result. I have a handle to my window, and I have a bunch of values going in. And I will handle whatever Windows gets back to me about. So let's have a look at this. Here's my main method, which I did not write either, right? I register stuff at the beginning, okay? And once I initialize everything, I just wait around, and I have an infinite loop here where I get a message from Windows. Whenever a message comes in, essentially, I translate the message, and then I dispatch it to whatever is handling my messages. Again, all handled for me. I didn't actually write any of this code. Here is, I'm registering, this is me registering for all these various things, setting things up, initialize my instance. When I start my window, I show my window, I update my window. Here's the callback, or it's going to be part of a callback. Let's go to Windows processing. Here we go. I have a message coming in. This message. I have a switch statement. It says if I have a command that is show the about window, show the about window. If the command is exit, I destroy the window. If the command, it's instead of command, it is a left mouse button down or left mouse button up, or the mouse moves, I handle the mouse events. If the event is paint, then I paint stuff. If the event is to destroy the window, I post a quit message and destroy the window, essentially. It's all, I get messages. When the messages come in, I deal with them. There's nothing special about this other than this function gets called whenever a message comes in. That's all it does. Message comes in, I deal with it. So every time I get a call to paint things, it means the image that I had there isn't looking like it should. Let's say I moved something. I drew a new shape. My mouse moved over things. Then I just call paint and I redraw the entire scene all over again. I might be calling paint 30 or 60 times a second. Mouse events might be way slower than that, but I might have a whole bunch at once. But I don't know the order and the timing of these things. All I know is I have a paint event and I deal with paint then. And here's the about dialog. Okay, that's it. We will look at this in a lot more detail very, very soon. So here are the pros and cons though for this. Hopefully you write less code. Now that's a pretty big thing. There's a lot of really tedious boilerplate code you'd have to write over and over and over again. MFC gets rid of that. Most of these GUI things get rid of that. You can reuse code between your applications, and it gives you a uniform look and feel. All your MFC applications look the same. But there is a massive learning curve, at least in my books. It can produce slower code because you're doing a lot of, it's boilerplate code that's designed for generic terms. You can't optimize it that other person's code, and it can be much harder to do exactly what you want. Like with MFC, you have no real control over a lot of stuff. In fact, we do weird things like there are global variables all over the place when you're dealing with MFC. It bugs me to no end. If you want a different look and feel, or if you want a new component, it's a lot harder to deal with. You're fighting against the system the entire way. So here it would be a normal Windows application, in case you're wondering, right? It has a nice frame around the outside, and there's a document in the inside. That's a framed window. It allows you to resize. It gives you a title. It gives you an icon. It allows you to maximize, minimize, that sort of thing. Here's a multiple document interface, right? I have a whole bunch of tabs. I have a bunch of buttons and icons and stuff like that. We are not touching this with a 10-foot pole. MFC allows it. It supports it. I would cry trying to make one of these things. So here's the one that we are going to be dealing with, the dialogue-based interface. It is fully self-contained. You won't have other things popping up at the same time. It's just a dialogue. It's a modal dialogue. So that's all we're going to be focusing on is the dialogue. If you make an MFC application, you do anything but dialogue-based interface, you're doing the wrong thing for us for this term. In case you wanted to know, well, let me just pause for a second and say, what's the difference between a modal dialogue and a modeless dialogue? So find is an example of a modeless dialogue, and this is a crappy example of a modal dialogue. I'd say it's a crappy example because there's better examples. Why would you want to block? So it means, if you can read, presumably you can, it means you're blocking the rest of the input for an application. When would you want to do that? One of the big ones would be you're trying to format your hard drive. Are you sure you want to do that? You're going to delete this file. Are you sure you want to do that? Modal dialogues are really useful for when you want to force the user to make a decision. They clearly know what their answer is, and you want to make sure they're not doing it by accident. Modal dialogue. Modeless dialogues, there are cases like for find where you want this floating window, but it can lead to problems, right? That big floating window prevents you from seeing things underneath it. So modeless dialogues, they don't block what you're doing afterwards. In fact, we have a bunch of modeless dialogues in MFC actually. But a modeless dialogue for find, for example, if I'm looking for a piece of text, I want to be able to edit the text, go back here, keep searching. Okay. I'm not even sure if it's a Windows 32 or maybe it's a 64 now, but we're going to be making a Windows 32 project. We're going to go to application settings. We're going to select Windows application by application type, and then we're going to, so if you're using a Windows 32 program using default values, and then we're going to leave most of the options empty. We're going to, so here's what we're going to be doing. I'm going to, normally if I wanted to do this, it would, let's see here. I have a different instance of this. So this was actually for just a Windows 32 project. What I did for model view controllers. I'm actually going to give you the project set up for you so you don't have to make it yourself, because a lot of things can go wrong. It would be a Windows application, and then afterwards I would have all of these particular instances. So we would normally leave a lot of this stuff out, but hopefully you won't have to deal with this. So I'd make a Windows application. It would be empty at the end. It would be essentially an empty project with nothing in it. But my main method has to have a brand new version of main that I didn't have before. Instead of my normal int main function call, it's twinMain, which is, it replaces the old main method, but it's for drawing. It's for GUIs. It initializes your program and waits for commands in a loop. I showed you briefly showed you an instance of this. We have a function called init instance, which is creating the window itself, and the Windows processing, it processes window commands. That's where the guts of your program are. Every time a mouse event happens, this handles it. Every time it says paint, this handles it. The Windows processing handles all the particular events. Initialize instance just sets things up initially, and this is the initial setup. But most of this time, this is pretty much given to you. Windows processing is the only thing that you really have to build yourself, or build much of it yourself. We also have a bunch of different things. So WM command is commands from the menu, Windows menu commands. So for example, exit and about. WM paint is for painting to the screen. It's when you refresh the window, when you resize a window, when you draw on the window, WM paint gets called, and you redraw the entire image, the entire window. WM destroy is when you close off your window. If I had a single threaded program and my paint method took its sweet time to do things, it would essentially would be do not respond when processing the message. So if it was single threaded and I did one thing at a time, if painting took too long, everything would be backed up. So instead, I paint blindly. We're going to talk about this with model view controllers. I paint blindly. I deal with mouse events blindly. I update things blindly. They're different. I keep those ideas separate, and that's what we're going to look at when we deal with model view controllers. So here's my paint method. It might look something like this. I begin paint. I will have it's a paint structure for PS, a handle to the window that I'm dealing with, and I'm going to get a handle pointer to a device context, an HDC. The handle to the device context, you can imagine it as a big bitmap, like a big image that you're drawing directly on top of. So my function says, get a big image that I can draw on, draw a bunch of stuff on that image. When I say end paint, it then will put that image right on this, put that image on the screen. So it's essentially like drawing somewhere else on a separate piece of paper on the side and then putting it up afterwards. So this function here, or this series of calls here, is I'm going to get a handle to a device context, a handle to this image I'm going to draw on. Then I'm going to, notice I have two for loops, 100 by 100 thing. It is going to give me a grid, 100 by 100 grid of pixels. I'm going to draw 25500, so red, green, blue, a red square that is 100 by 100 pixels. It's going to be drawn at the from 0 to 100 in both of these directions. So from 0 to 100 as a rectangle, or as a square, actually I should be more precise, a red square. So I will draw for each X and Y position, I will draw the color red for 100 by 100 area. I am then also going to just output some text, the word hello world at position 100, 100. I'm going to draw that right on the handle to the device context, draw it to the image with an 11-point font. And as soon as I say end paint, I will draw the red square and the word hello world on the screen. That's what this thing actually does. So hwind is a handle to a window, the window that you want to use. So for example, the application that you're dealing with, the background image that you're wanting to be drawing on. The HDC is a handle to the device context. It is the graphics component, the thing that's performing the action, and the paint structure PS holds information about painting. So I think the PS holds things like the brush size, what kind of brush you're using, what kind of pen you're using. So I'm going to maybe take a brief break here, just in case I've already done this lecture and I want to make sure I have a clean break. Okay, hold on one second when we get to the next thing, and we'll look at this.